Hello, we're here at the Big 5G event in lovely Austin, Texas. I'm Phil Harvey, editor at Light Reading, and joining me is Jason Wallin from John Deere. Hi, Jason.
Hi, Phil. How's it going?
Great. Thank you for making some time for us.
You bet. It's my pleasure.
You've got a speaking engagement here at the show, and we're excited to see that. But as a sort of a taste of what's to come, I wanted to ask you a little bit about, well, first of all, give us a little bit of info about your role at John Deere. You know, what types of things you're in charge of and what you do there.
Absolutely. I'm principal architect of infrastructure and operations at John Deere. I'm responsible for our intelligent edge solution, how we incorporate that into the manufacturing environment, and then what technology stacks we use in that environment.
Okay, great. So the manufacturing environment is interesting because the manufacturers, I think, have some rather unique characteristics or needs for connectivity. Can you give us an idea of like what has to happen for a manufacturing facility to kind of go from being unconnected to connected to maybe smart?
Excellent question. I think one of the things that I would call out is we've got a couple of legacy technologies that some of our larger facilities, as an example, we would have over 1,000 miles worth of Ethernet cable in each one of those facilities. So it's a significant investment anytime we need to change the factory. We're very anchored to that wire, and anytime we need to move things because of we change a factory configuration or by bringing a new technology in, it makes that very expensive to do that. Likewise, we have Wi-Fi in that space, but it's one of those where you have several hundred access points in that same size facility, administratively very hard to manage, and then also from a density, very hard to manage that connectivity as well, which is why cellular gives us a huge advantage in the manufacturing space.
Okay, so yeah, so the scale of the operation is one sort of connectivity challenge.
Correct.
The expense to change your mind on technologies and access technologies especially is another huge one. And then after that, it's what's delivering the best service. So whether like you said, Wi-Fi is great. There can be maybe some interference issues, or it's just the propagation part of it. You have to have so many hotspots in so many places.
Right. I think we have one compounding factor inside that as well. The 900-pound gorilla that we have of Industry 4.0. We believe 5 years from now, we're going to have 20 times the connectivity and connected sensors that we have on the shop floors to what we have today. We know from that experience, there is no way we can scale our wired environment nor our Wi-Fi environment to be able to meet that. And that is, again, a unique driver of why cellular is going to be huge, 5G specifically.
Yeah, so let's talk about, 5G is a huge enabler of your business and of connectivity in the manufacturing facility. Now, where do private networks fit in, and why are private networks an option that you're looking at, or maybe you've deployed?
Right. We've been in the private market here since 2020 when we did our first purchase of the CBRS spectrum that John Deere was able to do there. Okay. We spent the last 2 years implementing several proof of concepts at a couple of manufacturing facilities, both LTE and then 5G SA solutions.
Okay.
Those two solutions have really helped us inform what are use cases that we need to have on cellular inside the factory there. I think we've learned a couple of key things inside there. Number one, if things move around on the shop floor, it is always better suited to cellular. So we talk about AMRs, AVGs, mobile autonomous forklifts, or even just connected forklifts with human operators on them, even is an exceptional use case inside there. One of the other use cases that we find are things that move seasonally. So in model year changeovers or factory master plan changeovers there where we've traditionally had those cabled in the past,
right.
Being able just to pick them up over a weekend, move them, and as long as you've got power to that workstation again, everything's going to come back up and you don't have to have the electricians involved with pulling those extremely long Ethernet runs that we have inside our shop floors.
Yeah, and what's can you give us an idea of the scale of the operation? Because I think, most people know John Deere as, agricultural equipment manufacturer and a pretty big one, but what's the scale of the operation you're sort of looking after in terms of the manufacturing facilities?
Right, so excellent point, excellent question. We have about 60 manufacturing facilities worldwide and about that many warehousing operations as well to support service parts organization. As it sits right now, we've done those two proof of concepts. We are now fully committed into the private wireless networking, specifically the cellular 5G based solutions there. That really is going to be our lead technology in this space. We actively have 13 factories queued up right now, either in RF design or actual deployment in there to be able to support that. That is our goal, to complete those for the rest of fiscal 23, and seeing that grow again in 24 internationally as well. So
yeah, that's pretty interesting too, because it's like I said, we're not talking small scale by any means. It's a massive undertaking, as I can appreciate. But when you're talking about that many facilities in private 5G environment, what are some of the considerations, besides just the sheer scale of the operation? You mentioned RF modeling. Like, do you have to go to every site and sort of put a unique sort of schematic together for how where you're going to lay things out and that sort of thing? You can't just nail up a mast and
no,
send a signal.
Absolutely not. Really what it is, it's a site survey at each one of these locations that then, once we collect the use cases that they plan on running over the next several years at each one of these factories, marrying that up with the RF patterns that we have, designing that full redundant RF configuration, and then being able to come back and make sure that we've got enough bandwidth available to deliver where we're at going forward. As we think about these new facilities, a lot of times it really focuses on our new connectivity model, which is where we drive 80% of our connectivity over the cellular networks, 10% remains over the existing wired network, and then 10% will remain inside the Wi-Fi ecosystem as well.
Okay. How does, how do you handle the data? So that's the connectivity, sort of the radio access part. I want to say how to handle the data. I guess what I mean by that is, with 5G, it's a cloud native architecture, so it has some unique capabilities in terms of how close you can get the 5G core to your operation,
Correct.
That sort of thing. How did that play into your decision making?
Well, as a part of our smart industrial activity that we've done there, we've really tried to drive a cloud-like experience into our factory environment 12, just to kind of match what we've already done with the hyperscalers. So we have things like container as a service available for us at each one of the factories, as well as database as a service inside there. And again, we know most of the cores today run in a Kubernetes type environment, in a containerized environment there. So we're well positioned to be able to have that connectivity and the cores running at each one of the facilities, which then reduces the latency of our connected environment there. Also, we have a choice then, because we've got this technology at the factory. Do we run the models locally for our AI, ML, and CVML type use cases, or are those models that we train in the hyperscalers then bring back and run that in a hybrid mode to be able to do that, allowing us to decide what runs inside the factory and what doesn't, and how do we keep continued operations and
that's
manage
interesting.
that.
Yeah, so you're never really completely committed to either one. It just sort of depends on what you find best for that situation.
It's totally use case driven at that point.
Oh, that's interesting. Yeah. What would be an example of a use case where you would want to keep more information in the facility, or more, or in the under your own control versus sending it to the cloud?
Excellent question. I think, as we think about mistake proofing, a lot of that really matters at the factory, being very local and being able to make an immediate decision and say, yes, we met the conditions, or no, we didn't. So in our harvester example, we build combines, and our X9 combine, which is the largest combine that we make, has about 18,500 parts in it. We record today with our Wi-Fi as well as our Ethernet connection, every torque setting on every bolt that we put into that. So we know whether it's a plus or minus 1 foot-pound spec or a plus or minus 50%, where you've got a big range inside there, what goes on with each one of those bolts. But the cellular use cases, as we bring those out, really are enlightening to us in what we can get away with doing that just wouldn't be possible in that older ecosystem. So we would be able to take CVML as an example. If at a workstation, an assembler was to put in 12 bolts, torque those 12 bolts, we would know that 12 bolts were torqued, but we may not determine that each one of those are in the correct position. So we can use CVML, take a picture of that subassembly, and then compare that to a golden image, and then determine that, yes, it's good. We can now move it on to our next line in there. Likewise, around the fabrication side, we can do a lot of that with our welding environments too. So we can count the the number of welds that occur at a station, as well as how much voltage, amperage, and wire were fed into each one of those welds to help us determine, did that hit the design spec for what each one of those welds should be, and did they go in the right sequence, allowing us to take a problem out before it even makes it to the next step in the manufacturing process.
So you go to a point where you're not just eliminating waste and making the whole operation more efficient, but also a massive safety, a preemptive safety sort of check, I guess.
Absolutely. And when you think about it, with our customers, when they get into their critical seasons, whether that be harvest or planting, they really have a very small window in which to do their operations. Planting season in the U.S., as an example, is optimized in a 10-day window. Every day that they miss outside that window, it costs our farmers 1% of their overall farm income for each day they miss. So it is significant that when they're ready to go and when the conditions are right, they have to have a machine that's going to be able to deliver that 100% uptime, and they can run as long and as hard as they need to be able to go through that process. And that's why we put this level of mistake proofing in there, just so we can deliver the product to them that they need to rely on.
How do you let's see how annoyed you get with my stock tech journalism question of when I'm talking to somebody like you, I am curious as to how you define the network edge, because everybody has their sort of own way of looking at it or whatever, but you've got several edges. You've got facilities that could be the edge of the network, but you've also got your customer locations and and their edge. How does that sort of come together to you, or does it even matter?
So we have multiple edges. You're absolutely correct in your assessment there. For the intent with the private 5G networks, those are the manufacturing edge there. But when we think about our products and the number of sensors that we have on our equipment, as you know, at CES this year, we announced our autonomous tractor and then planter technology that allows us to plant and fertilize each individual seed as it goes into the ground uniquely relative to wherever it was done. Right. In the past, that was all done at a farm level or maybe a field level. Yeah. Now we're able to manage that at an individual plant level, and that, being the farmer's edge there as a part of the ecosystem is revolutionary in how we're able to do that.
Yeah, indeed. Well, I appreciate the information. I appreciate you not tossing me off for the question, tossing me out of here for the question, and I appreciate your time. You've got a presentation to get to, Jason. Thanks so much for your time.
Thank you.
Appreciate it.
You bet.